Hi everyone, my name is Sindhuja, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology, Hyderabad. Today I have come up with another topic called window aggregations in stream processing and analytics. So, the overview of today's presentation involves window aggregations. So, in that window aggregations, we have two types. The first one is tumbling window and the second one is sliding window. So, now we'll move on to the topic. So, what is window aggregations? First, we'll look into the topic. Stream processing systems often feed themselves an action, event or elements that occurs in real time. As we are discussing about stream processing, which is real time analysis, those stream processing has number of events or number of actions we can call. So let us take an example, social media messages. So searching for social media messages, we can call it as one event. Clicks on web pages, those are number of events. And e-commerce transactions, let us take e-commerce an example. Every transactions we do via e-commerce are considered as number of events or number of elements. Financial events which are related to banks and insurance companies, those transactions are also considered as events. And the last one is sensor readings are frequently examples or events. So sensor reading, the data which is coming from the sensor are also considered as an examples of number of events. So everything we calculate in real time as an event. So in stream processing, our streaming application, so the streaming application has a centralized view of the logs of several places. So here I have told you stream processing works as a centralized view of logs. So here the number of systems are works based on cluster model. Okay, so number of machines are work based on cluster model in stream processing. So each and every system has generated number of events. So those are nothing but logs. We can call it as a logs, like shop location or simply a web service of a web application, or we can call it as a number of events which are generated from web servers from any web applications which is related to internet. Even though seeing every transaction individually, so we'll consider each and every transaction individually, even though might not be practical. So calculating individual events might not be practical, and those are not as a particular events which is related to any application. We might be interested in the events overseen a recent period of time. Okay, so instead of calculating each and every event individually, we can calculate events, how many events are generated based on some period of time. Over a period of time, we can segregate or we can aggregate the events. For example, last 15 minutes or last 1 hour. So the number of events happened in a real time for last 15 minutes. If we aggregate the events based on time, okay, and last 1 hour, how many events are generated. So that in that manner, if we can calculate the events, that is nothing but storing web logs. Now let's move on to the continuous topic. Moreover, the very idea of stream processing is that the system is supposed to be long running. Okay, as a stream involves continuous flow of data. Okay, so each and every event will occur continuously with a long running. Okay, with a long running of events are happening, dealing with a continuous stream of data. Okay, so in that particular process, continuous stream data is going to generate it. We can calculate those events according to the time. As these events keep coming in, the older ones usually become less and less important. Once the data is continuously flowing from the streams, okay, the past data we can ignore, or those are less importance, we can say. Those events are less importance which are already completed. Okay, so to whichever processing you are trying to accomplish, we find many applications of general or regular and recurrent time-based aggregations that we call windows. So each and every application generates a number of events. Okay, those events are general and regular also, and those regular and recurring time-based aggregations. Okay, recurring means which is continuously generating, so based on some time. So those events are, we can call it as a windows. Okay, one event is one window, we can call it as windows. So Spark supports two kinds of event time windows. Okay, Spark supports, as we are talking about Spark. So Spark supports two kinds of event time windows for grouping streaming data. So to group streaming data which is continuously flowing into the data source, we can group that streaming data into two kinds of windows. So the first window is nothing but tumbling window. Okay, the first window is tumbling window. Second window is sliding window. So we are going to deep into this particular topic. So what is tumbling window? Okay, tumbling window is fixed size and non-overlapping overlapping events. Okay, tumbling window is nothing but fixed size which have some fixed size and non-overlapping. Okay, each window is individual and does not overlap on each other. Continuous intervals on some particular continuous intervals. Each event is assigned to exactly one window. Okay, each event is considered as one window. Okay, one event is one window and those events are individually happening, does not overlap on each other. When comes to sliding window, these are also fixed size windows but overlapping windows. Okay, we can say both are fixed sizes, but when comes to sliding window, these windows are overlapping, which means that one window can overlap on another window. Let us take this is event 1 and we can consider it as a window 1, and this is window 2 and event 2. So these two, there may be chances of overlapping each other. Okay, there may be chance of overlapping each other, which is nothing but sliding window, as name suggesting that one window is slides on another window. If the slide interval is smaller than the window duration, there in this sliding window, there are two factors we have to mainly focus on. The first one is sliding interval and the second one is window duration. Okay, window duration. Events maybe belongs to multiple windows. Okay, here events are belongs to multiple windows, whereas it is a combination of all the windows. Next, move on to the tumbling window individually. Okay, then what is tumbling window? We'll go deep into this. The most natural idea of a window aggregation is that of a grouping function each into x period of time. Okay, which means that grouping of multiple events over a period of time. Okay, here suppose this is one window, this is another window, this is third window. So grouping all these individual events are over a period of time. Suppose for 15 minutes. If I can calculate each individual events for over a period of time, which means that 15 minutes of time. Okay, for example, the maximum and minimum temperature each hour or the total energy consumption each 15 minutes. So here if we take an example, maximum and minimum per 1 hour. What is the value of maximum minimum temperatures per 1 hour? Okay, this is nothing but specified time. Okay, some specified time, and maximum minimum temperatures are, we can call it as an events. Okay, so grouping events with respect to time, which is nothing but an example of tumbling window. Okay, next, notice that time periods are consecutive and non-overlapping. As I have told you that time periods are also consecutive and non-overlapping. Okay, we call this grouping of a fixed time period in which each group follows the previous and does not overlap, which is nothing but tumbling window. Okay, here when comes to tumbling window, windows are individual and also time is also different. Okay, there is no overlap between windows as well as time differences. Okay, everything are considered as individual. Okay, tumbling windows are used when we need to produce aggregates of our data over a regular period of time. Okay, so here if we want to aggregate some data based on some time, in that scenarios we can prefer tumbling windows. Okay, these can produce proper outputs with each period independent from previous ones. Okay, as I have told you that these are the independent events based on some time intervals. As you can see in this particular diagram here, I have divided windows into for some 10 seconds difference. Okay, individual events has some 10 seconds difference. If you can see here, this is my 0th position. From here to here, I have divided as 10 seconds. Again for next 10 seconds, like that, it is going in a consecutive way. Okay, and if you can observe here, these boxes represent one window. Okay, here this box represent one window, and here the rounded ones showing the events. Okay, here we can say that 3 events are happening for this particular window. Okay, 3 events are happening over a period of time which is nothing but 10 seconds, and these all are non-overlapping and all are individual, right? So there is no overlapping. The main 2 factors we need to focus on tumbling window is nothing but one is with a specified time, and the next one is no overlapping. Okay, these 2 are the major facts we need to focus while dealing with the tumbling windows. Now let's move on to the sliding window. What is sliding window actually? Sliding windows are aggregates over a period of time that are reported at a higher frequency than the aggregation period itself. So here, which means that there may be chances of the higher frequency over a slide, over each slide. Okay, which means that higher frequency, which means that the happening of event time is more. Okay, which means that window duration, there may be chances of window duration more with respect to slide. Okay, window duration can be more with respect to slide duration. Okay, here we need to focus on frequency as well. Okay, frequency as well. So that is another factor that adds in sliding window. So sliding window refers to an aggregations with 2 time specifications. Okay, we have to consider 2 time specifications. When comes to tumbling window, only 1 time specification, but here in sliding window we have 2 time specifications. Okay, what are those 2 time specification? Means the window length and the reporting frequency. Okay, the window length, and second one is the frequency. Okay, it is like a grouping of function over a time interval x reported in each frequency. Okay, here the third part also adds into the sliding window. I mean, we are grouping the events in the same time, calculating the time in the same manner. We are storing the frequency as well. So if we take as an example here, the average share price over the last day reported hourly. Okay, here we can say that average share price, we can call it as an event. Okay, average share price, we can call it as event, and last day, which is nothing but frequency. Okay, last day we can consider it as a frequency. And what is the time interval? For hourly basis. Okay, for hourly basis. So here we have 3 factors. Okay, especially we have 3 factors, which is nothing but event, time as well as frequency. Okay, as you might not notice already, this combination of a sliding window with average function is a most widely known form of a sliding window, commonly known as a moving average. We can call sliding window as well as moving average. We can construct and maintain a sliding window by adding the most recent data and removing the expired elements. Okay, here when comes to sliding window, we can remove the past data. If the data is flowing continuously, we can ignore the past data and we can stick on to present data. Okay, we can stick on to present data. Note that windows are particularly, tumbling windows are particularly case of sliding windows in which the frequency of reporting is equals to the window size. Okay, if I can take tumbling window as an example. Okay, in tumbling window size is equals to frequency, but when comes to sliding window size is more than frequency. This is the major difference between sliding window and tumbling window. Okay, now we can see here the diagram for sliding window. As I have told you that these are not the individual windows, these are the grouping of events, right? Here we can say that we can calculate the windows based on some group. Okay, based on some group. Here instead of executing individually, in sliding window all the windows are working as group. Okay, and each and every event is, there may be chances of overlapping. Okay, overlapping. So while focusing on sliding window, we have to focus on three parts. The first part is that these are not individual events. Okay, and these are overlapping events. Okay, if you can see here, if I have considered for 10 seconds how many windows and how many events are going to happen, means I have divided here for every 10 seconds. Okay, but for counting and calculating sliding window, we need to take here as a 30 seconds, not individual, which means that it is for adding 30 seconds we have to add for every 10 seconds, right? From 0 to 10 is one window, and 10 to 20 is another window, and 20 to 30 is another window. So collectively we are calling it as sliding window, which are overlap on each other. So here three windows are calling it as a group is nothing but sliding window, and there may be chance of overlapping on each window. And if another point, if we consider, if my 0 to 10th window, if I have a data which is considered as past data, right? Because the event and the window has started from 10 seconds here. Okay, not from 0, here from 10 seconds it has started. So I can ignore the past data. Why? Because already 0 second to 10th second the data has already passed to next window, which is from 30th to 40th second. So I can ignore the past data. This is the speciality of sliding window, which can reduce the storage. So here sliding window with a window size of 30 seconds. Okay, as you have observed just now, it is a 30-second duration, and reporting frequency is for every 10 seconds. Here we can consider each and every 10 seconds as a frequency, and the combination of 30 seconds as a time. Okay, window size. In the diagram we can observe an important characteristic of sliding window. Okay, they are not defined for period of time smaller than the size of the window. There are no windows reported for time 0 to 10 seconds to 0 to 20 seconds, right? So here I can say that this is a combination of multiple events. So now we look into the syntax for window functions. Okay, Spark uses the window function to define tumbling and sliding windows. Okay, window function is nothing but to define tumbling and sliding windows. We have to use window functions. So here window, the first syntax is window, the parameters are time column and window duration. Okay, the first one is time and window duration. Okay, so here the first form shows a tumbling window. This is nothing but tumbling window. Okay, where slide duration and window size and start time is 0. Okay, here slide duration equal to window duration. Why? Because slide duration is individual and window duration is also individual. So we can call it as these two are similar or these two are equal. And when comes to sliding window, here as I have told you, window duration is greater than slide duration. Okay, why? Because there is a chance of overlapping, right? That is the reason. So window time column factor is common to all, and window duration and another factor here added as slide duration. Based on this windows, how many times the events are sliding over a period of time. Next, time column and window duration, slide duration and start time. Okay, with respect to start time also we can call it as a window. Okay, here second form defines a sliding window. As I have told you just now, those are overlapping. And the third form this this works with respect to starting time. There may be chances of changing starting time, right? So we can write syntax for 4 factors. Here time column is common for every third, every sliding, and window duration and slide durations are also common, and the start time is additionally based on each and every start time there may be chance of changing the start time, right? So we can calculate that. Now if we can see as an example with respect to timestamp and minutes, okay, here tumbling windows are non-overlapping, right? So here as we can observe here syntax, the first factor which is nothing but timestamp. Okay, just now we have seen the syntax, right? This is the timestamp of any devices, and for every 5 minutes the window has to move, so which is nothing but window duration. Here my window duration is 5 minutes in tumbling window. And what is the individual time, window duration for my events are 5 minutes, next 5 minutes, and next 5 minutes. So here you can observe for every 5 minutes blocks are going to created. Okay, blocks are going to created. Here you can observe if it starts at 12 o'clock, my event has started at 12 o'clock, it has to run up to 12:05. It has to run up to 12:05. So this is a 5 minutes of window. Again, if my start time is 12:05 and it has to run up to 12:10. Okay, this is my next window. So here tumbling window works as an individual windows. Here the window duration of this example is nothing but 5 minutes. Okay, event, each event belongs to a single window only. As I have told you, each event belongs to for 5 single window, 5 minutes single window. Common in periodic summarization or batch like grouping. Okay, here we can call it as a batch like grouping. It is a grouping of each and every individual event. And if comes to sliding window, these are overlapping windows, right? Here as a first factor we have taken timestamp, okay, which is not common to every sliding window, right? And next here the first factor is represents window duration, okay, which is common in tumbling window, right? As a part of third factor, here it has added slide duration, okay, slide duration. So here the important point is that window duration has to have greater than slide duration. That is the reason events are overlapping. Okay, events are overlapping. If my window duration is 10 minutes, okay, 10 minutes, for every 5 minutes the window has to slide on another window, okay, another window, which means that here out of one window I am getting 2 slides, okay, which means that one slide has to, one window has to slide on another window for every 5 minutes, okay, which means that window 1 has to slide on window 2 for every 5 minutes time duration. Okay, that is the reason sliding windows we can call it as overlapping events. Okay, if you can observe with an example here, this creates 10 minutes windows emitted every 5 minutes. Okay, emitted every 5 minutes. Example, if we calculate via numbers, if my event started at 12 o'clock, it has to run for 10 minutes. Okay, it has to run for 10 minutes, 12 to 12:10. Again, if it has to start with 12:05, it has to run for again 15 minutes. Okay, again 15 minutes. Okay, why? Because it has started at 12:05. So if my event has started at 12 o'clock and it runs up to 12:10. Okay, again in the middle another window has started. Yes or no? Here 12:05. At the time of 12:05, it has started another window. So here window 1 and window 2 are overlapping, which because it has added in the middle itself. Okay, it has added in the middle of window 1. That is the reason we can call it as these two events are overlapping on each other. Events may contribute to the multiple windows. Here there may be chances of getting multiple events, right? Why? Because there may be chances of getting overlapping. offer more frequent updates with longer aggregation covers. Okay, via sliding windows we can get more frequent updates. Okay, next, at what time exactly the next window is going to start, this kind of updations we can get for a shorter period of time. So this is all about window aggregations with related to stream processing. So we can consider each event as an windows. Okay, thank you so much.